So in Chapter 3, Section 4, General Annuities, and we are still working with the annuities where there is simple interest for part of a period. So for number 36, you're supposed to try this. You should have tried this one on your own, and just some highlights of the problem. You're converting things to 6-month intervals, so you're from quarterly to 6 month, because here we have beginning of each quarter, and then we're compounded semi-annually. So your simple timeline should have had, again, because it's beginning of every quarter, so you should have had something here. So your payment was 700, so it should have had 700 here, 700 here, and then at the 6-month mark, that's where you're moving them to. That's your R. So this one moves 3 months, this one moves 6 months, and R should be 1,424.68. If you want to see more details, check the online notes, okay? Or you can email me. And then for your summary going forward here, this is in S7 for born, where your N is 7, and then your M, working it out, should be 3. And for that answer, you should get 11,476.54 cents. Okay? So again, this is just to help you think it through. So jumping to 37. 37 is similar. Again, this one you should be able to work out on your own. If you can't do it yet, go ahead and watch the next video. So we're going to work on number 38 right now, and then I'll leave a minute. I'll cover how to do this one in the next video, so you have a chance to work on it. So we're going to jump to 38. Okay, so here again we have the same issues that we're dealing with. Okay, so let's go ahead and read it. So here we have quarterly deposits are made into an account to accumulate $10,000. So already that word accumulate means we're dealing with some type of SN, either SN, SN due, or SN foreborn. And we're trying to accumulate that on January 1st, 2020. So first thing we do is just make our general timeline. We know this is January 1st, 2020, and we're trying to get that $10,000. Okay, so the first deposit is made January 1st, 2014, and the last deposit is made on October 1st, 2019. And again, these are quarterly. Okay, quarterly. Find the size of each payment. So we're trying to find R. Okay, so our second payment would be 4/1/14. That would be our next R. Okay, so that's what we're trying to find. And then we're assuming that the account pays 7% interest compounded annually. So here again we have that discrepancy between quarterly and annually, and that simple interest is paid for part of a period. Okay, part of a period. So we have R, and then we're going to have X. Okay, so this is kind of our general timeline. Okay, so now we have to work it out between the simple and the regular. Okay, simple and regular. So because here we have that annual piece, instead of calling these R, we're going to call them X, because that's not actually going to be the regular payment that we're looking at. Okay, the regular payment is going to be on our compound timeline. So we're just going to break this up into the 2 timelines. Okay, so in our compound timeline, we're making things every month. So remember, with our simple, we're going to take those quarterly payments of X, and we're going to move them down to the 1 year mark. 1 year mark. So we're going to move this one 3 months, 6 months, 9 months, and 12 months. Okay, to get our R. To get our R. So our R is actually at the end of each year. Okay, so that means that this is really S, and then if this starts in 2014, so this will be 2015, so it's going to be S6. Okay, because we're going to make a payment in 2015, 2016, 2017, 2018, and 2019 and 2020. Okay, so that's 1, 2, 3, 4, 5, 6. Okay, so this is our N. So our N. So we have to figure out two pieces here. We have to figure out our R, that's at the end of each year, and then we're going to break that up into our quarterly payment here. So first, by taking our R, we know that we have S6 is equal to our 10,000, and our S sub n problem is R times 1 plus I to the 6 minus 1 over I. So here our I, because R is 0.0, let's put that up here, sorry about that, 0.071, I know this is a mess, 0.071 over 1, 0.071 over 1. Okay, so we're going to find that coefficient and divide, or you can use the explicit formula. I'm going to do the coefficient and divide just for, again, consistency. So 1 plus 0.071 over 1 to the 6 minus 1. Whoops. And then we're going to divide that by 0.071 over 1. So our coefficient is going to be 7.17 and change. And again, we're not going to round that. We're going to divide by that answer. So we get 1,394 and 44 cents, because again, we're going to round up in the payments. Okay. But we're not done, because we're still looking for the quarterly payment. This is the yearly payment. So now we have to look back over here at our piece, and we're going to take this as this number, so 1394.44, and we have to figure out what each of these are. So we have 1394.44 is equal to X. We have 4 payments, 1, 2, 3, 4, so it's going to be 4. Plus our interest rate isn't going to change, 0.071, and then we're going to multiply that by, this one has to move 12 months. This one moves 9 months to get from 3 months to a year. This one moves 6 months to get from 6 months to a year. And this last quarterly payment would move 3 months. And again, that's all over 12 because that's representing months. So here we can't use that formula. But when we add those together, 12 plus 9 plus 6 plus 3 gives us 30. So it's going to be 30 again over 12 because that represents the number of months that the money is sitting there. And then we're going to find what this coefficient is. So 4 plus 0.071 times 30 over 12. Okay, so I'm just putting that in my calculator. I'm not using parentheses, just putting it straight in. And we get 4.025. So 1394.44 equals X times 4.0425. And then I'm just going to input my R value and divide by answer, because again, there's no need to introduce more rounding errors than we need to. So $344.95, because again, we're going to round up 4 payments. So this will be our quarterly payment to accumulate that, assuming simple interest for part of a period.